Very good. Sorry, I'm used to it. Okay, my name is Hershkovich. I'm Business Development Manager at AWS, focused on vision and language AI. And today my goal is to inspire you a little bit about the art of the possible, where we see our customers and partners pull together different AI services in order to build solutions that address all sorts of challenges across verticals, from need to cost reduction, increased productivity, monetize assets that they own, and reinvent experiences that matter to them. But first, some level setting. Our mission at AWS is to put AI in the hands of every developer. Said other words, we try to simplify the use of machine learning, make it even boring, so that anyone can use the predictive nature of machine learning models across any type of application. And we do that in three ways. First of all, we provide the broadest and deepest set of machine learning tools, from optimized frameworks for expert practitioners to machine learning services that reduce the heavy lifting of building, training, tuning, and deploying machine learning models, to encapsulated pre-trained AI services that allow any developer with no machine learning background to use artificial intelligence and solve specific, very common problems like translation, transcription, or computer vision. We also provide a cloud environment that supports the machine learning development and ongoing life cycle, with a very broad set of databases, data lakes, analytics tool, everything that's required in order to support the data aspects and data management and storage and other aspects of the machine learning lifecycle. From our perspective, there's basically, you can look at the machine learning services as a three-layer stack, technology stack, where at the bottom we have our machine learning frameworks and infrastructure. This is where the proficient, expert practitioners operate usually. The layer above that is the machine learning services, which is essentially using Amazon SageMaker as a development environment for machine learning, developing machine learning models where there are a lot of assisted tools to go through the process of build, train, tune, and deploy. Again, removing most of that heavy lifting. And finally, at the top, there are the AI services, which are the pre-trained services. And I'm going to focus specifically on the blue ones here on the left, which are vision and language services, where we see everything from computer vision with Amazon Recognition there, text-to-speech with Amazon Poly, speech-to-text with Amazon Transcribe, Amazon Comprehend for NLP, like key named entity extraction, sentiment analysis, and neural machine translation with Amazon Translate. Amazon Textract is kind of an OCR on steroids. Amazon Kendra is one of our latest releases from last reInvent, machine learning powered search, enterprise search. And finally, Amazon Lex is conversational interface. So just to set the context of the things that I'm going to show you now and how our customers use these different services to solve all sorts of real-world problems. Okay, so I'm going to focus on four main use cases, very common use cases. There are obviously many more, and I'll try to get to a couple more right towards the end. And the four I chose to focus on are extremely common across our customers and what they do. So, dive right in. First one is analyzing rich media in order to get insights from media and then be able to drive better monetization of these assets. For example, understand what is actually being displayed and being able to perform contextual ad placement within video. Develop media libraries, rich media libraries that are searchable using transcription and computer vision, and basically creating a lot of rich metadata so that video and audio becomes searchable and accessible and monetizable, as well as improve productivity and reduce costs associated with the entire media lifecycle and production pipeline. One nice example is C-SPAN. C-SPAN in the US, for those of you who are not familiar, is a network that streams or broadcasts and records public proceedings in the US. So, for example, House of Representatives, US Senate, other public forums. And they produce an enormous amount of content because they basically do not edit any of the things that they record. So they produce thousands and thousands of hours of video every year. And until recently, they put people to work in order to identify the speakers in the video and index all these recordings manually. They started using at one point Amazon Recognition, which is our computer vision service for video and images. And they were able to label and produce labels and index those labels automatically and double, more than double actually, the amount of video that they were able to index every year. So still people are looking and editing or overseeing the output, but most of the process is already automated. Now you can add transcription to that and transcribe all the audio associated, use NLP on top of that with Amazon Comprehend and extract key entities and phrases, so you can actually then index all of that and fine-tune your search results to focus on specific topics, or who said what, he said, she said, kind of type of search. Another interesting example is in content production, in subtitling, captioning, and voiceover. So last year at Remars is our, this is the second year of Remars. It's our conference, annual conference on artificial intelligence, machine learning, space, and robotics. Will be in June in Las Vegas this year, hopefully. Right now, lots of things get canceled. But last year at Remars, TED conferences presented a test that they did integrating automated speech recognition and neural machine translation into the subtitling production process. And what they found is that by doing that with TED translators, which is a community of volunteers all over the world, they were able to accelerate the production process of the TED Talks with subtitles in all the languages that they cover, and they expect that they would be able to produce 3 times more subtitled content or TED Talks for all of us to watch. Let's see.
But the AI era of discovery continued, and more scientists poured their souls into it. About 10 years ago, the grand AI discovery was made by 3 North American scientists, and it's known as deep learning. Deep learning is a technology that can take a huge amount of data within one single domain and learn to predict or decide at superhuman accuracy. For example, if we show the deep learning network a massive number of food photos, it can recognize food, such as hot dog or no hot dog. Or if we show that many pictures and videos and sensor data from driving on the highway, it can actually drive a car as well as a human being on the highway. And what if we show this deep learning network all the speeches made by President Trump? Then this artificially intelligent President Trump, actually the network can... You like double oxymorons, huh? So this network, if given the request to make a speech about AI, he or it might say,
"It's a great thing to build a better world with artificial intelligence."
And maybe another language.
人工智能正在改变世界。
You didn't know he knows Chinese, did you?
Okay, there are many permutations of this process. Some of our partners like SyncWords and Caption Hubs and Trint and others use automatic speech recognition and neural machine translation as a way of providing over-the-top real-time subtitles. Several of them are being broadcasted around the world for major networks, and sometimes human in the loop. But there are great examples in that space, and that was my first common use case. I wanted to jump straight to the second one and talk about contact centers and the application of AI in contact centers. Now, language AI plays a huge role in contact centers, becoming extremely popular. Agents sitting in front of an agent desktop get a call, and as they speak with the person on the other side, automatic speech recognition transcribes the content of the call. As that happens in real time, natural language processing analyzes the text, extracts entities, and identifies different custom entities and classifiers on that text so that you can actually understand what is the topic of the conversation, and a recommendation engine can take action and tell the agent what is the best course of action in real time, or redirect the call somewhere else if they don't think the agent is the appropriate person to handle the call. At the same time, also providing for non-native English speakers, providing a real-time translation of the conversation so that nothing is lost in translation, and that the agent understands the customer as well as possible. And this obviously allows for better call resolution, faster call resolution, and greater satisfaction to customers calling for customer support. But there are cases where most companies, a lot of organizations actually, are looking to prevent calls from ever reaching the call center while increasing customer satisfaction, which is not an easy task. And they do that using conversational interfaces, chatbots. And the opportunity here, using voice as an interface, using the ability to answer frequently asked questions or common questions that are predictable from all this rich information that was collected in the call center. All those transcripts get analyzed with natural language processing. All that analysis allows us to determine what are the common questions asked and what are the best answers. And that can go into configuration of a chatbot like Lex, and understanding all the customer intents, like the National Health Service in the UK introduced a chatbot, basically a conversational interface, to answer a lot of the calls coming into the call center because wait times were very high. So customers were not happy, they were not getting their questions answered. At the time, it was pre-Brexit. It's focused on calls about the European health insurance card. There were a lot of common questions, and the bot was able to answer and reduce 26% of the calls going into the call center. What that means that customers got their answers faster, but those that needed to reach an agent could do so faster as well and get the answers to more complicated issues, right? So the use of translation, natural language processing, transcription, and conversational interfaces around the call center have been so popular that we've actually launched last year a new service called Contact Lens on top of Amazon Connect, which is our call center in the cloud, as we continue to implement specific solutions for customers with different AI services. Another third use case, focusing on information extraction from documents. This is the space of document digitization, hard word to say in English with a Hebrew accent. But this is not just for document management purposes, which may sound a little boring. There are a lot of really cool applications where if you can understand forms and tabular information and the context between the different relevant items on the form, you're able to perform analytics, apply NLP, identify entities, and do a lot of cool things. So the year before last, so last December, we've launched Amazon TextRack, which is kind of, as I said, kind of an OCR on steroids that can understand relationships in forms. So for example, first name and associate that with the first name in the form, last name and so on. Tabular format, correlating content of columns with the actual content of the tables, and producing a JSON structure that allows you to actually run analytics right there and then on the information that was scanned and OCR'd. Using Amazon Comprehend Medical, the Beth Israel Deaconess Medical Center, which is a Harvard Medical School hospital, it's a learning hospital, when they send patients to surgery, they require the patients to fill out a health and personal information form before surgery can actually happen, and they need people to correlate that information between the form and the health records of that particular patient. Now, those forms normally are sent by fax. Don't ask me why. But when they reach as a fax, they reach as an image, and people took a lot of time correlating those with the health records, and that can cause delay in needed surgeries and other procedures. And so what they did is they implemented an automatic solution using Amazon Comprehend Medical, which is the healthcare and life sciences version, basically an NLP service trained on healthcare and life sciences data, that was able to using TextRack, extract all the text from the forms, and then using Comprehend Medical to understand the different elements, things like medications, conditions, disease states, procedures, and so on, and correlate that automatically with the relevant health records, and then alert the staff that the record was found. This reduces the amount of wait for surgeries and reduces the possibility or the likelihood of postponing necessary surgeries. The fourth common use case is search. Now, this is an interesting one. So last reInvent, this is 3 months ago, we've launched a new service called Amazon Kendra, which is enterprise search service, which is fully machine learning powered. And the reason we did that is because of a lot of our customers came to us and said, look, we don't necessarily understand why, but our search engine does not produce great results. Search accuracy is very low, and when we're searching within any company, within any enterprise for information, we end up with gobbledygook. We end up with a list of links that are not associated with the keywords that we put in the search bar. And we've decided we're going to jump on this, and we realized that the main reason is because search engines are mostly keyword engines that were invented to address a world of structured content, databases, data warehouses. But the world has changed dramatically over the last few years, and 80% of enterprise content today is actually unstructured text. From wikis to blog posts to project documentation, enterprise or corporate policies, and so on and so forth. And so we've decided we're going to enable what needs to happen is a rethinking or reinventing of enterprise search by using natural language questions to ask the questions that are in your mind that you usually have to translate into keywords and then get all the irrelevant information, and being able to understand the concepts. If I'm asking who is AWS CEO, get an answer, Andy Jassy, from somewhere in some document, somewhere across the enterprise, rather than get a link to a document that may or may not contain the answer I need to read through and find out that it's not relevant. All right, so, oops. All right. Huh? No, still jumps. Okay, so we decided we're going to reinvent enterprise search, and in a world of unstructured content, we use multiple machine learning models under the hood, reading comprehension models that are able to understand concepts in text, using natural language understanding to understand what are we actually looking for. For example, factoid questions, who is, where is, what is, and so on and so forth. Even using keyword queries that can leverage the same machine learning models in order to find and correlate between entities, keywords, and entities and produce better results. We've also introduced FAQ matching because not every question has a single answer. Sometimes we have curated content, so questions that we anticipated, and we have an authoritative source for the answers. And document ranking machine learning models that are able to produce that list of relevant links but make them more relevant because we understand the context of the question and understand the context and the concepts that exist within the unstructured text. Now, search until recently, this is interesting, until recently it's been, it used a lot of AI, still. I mean, we haven't invented introduction of machine learning into search. But the way that it used AI is that if there was unstructured content, it would apply NLP, extract entities and key phrases, and then index them on a flat index, like Elasticsearch, for example, and then ask people to use keywords to search, losing all that richness and all that context and the concepts and understanding what we're actually searching for. So we've introduced Amazon Kendra, where you can actually use natural language queries as well as keywords to ask the questions that are in your mind, what you're actually looking for. Now, this is an example where I uploaded the machine learning blog at AWS from last year. So you can ask all sorts of questions about machine learning at AWS using Kendra. And you can see, you can actually ask questions. Now, Kendra can answer questions that are in the text. It's not an analytics tool, it's a search tool. But it understands concept and the context that exist in text and allows you to surface those answers up. A great example is Woodside Energy in Australia, where they need to make sure their employees, they're a gas, oil and gas company. They do gas drilling, very relevant to what's going on in Israel today, a big topic today. And they need their people, their employees, to make better decisions on the job, have access to information that they need when they need it. And until now, they had to search through project documentation to find out answers to questions like, what is the length of the pipeline at Pluto, at the Pluto site, which is one of their gas drill sites, right? And so now they're able to ask that question and get an answer, 127 meters. And the person asking the question is asking because they need to perform an action. And they can take that action right away, not spending any more time. You can see the frequently asked questions tab comes up when a question actually correlates, fuzzy matched, to a question that has been curated and is available within a separate index in Kendra. Not going to go too much into detail of how it works, but the issue of search has become a machine learning problem. And the machine learning solution is today sitting at the top of that AWS machine learning stack that I mentioned, unlike where other search solutions were sitting until now, search services like Elasticsearch, Amazon Elasticsearch service, which is sitting with analytics and data, right? Today, this is truly a machine learning problem and a solution. I want to show you, I think, this runs automatically. Sorry. I want to show you a couple of other examples. We have 1 or 2 minutes. So I'll just run quickly through another couple of common use cases. One is very relevant today, unfortunately, telemedicine, where medical staff needs to support people that are either in quarantine or far away or a very large crowd of patients. And this was made by a partner of ours, SourceFuse, where what you can see here is the use of different AI language services like neural machine translation,
Como te va hoy?
Spanish in an English accent,
Yo tengo demasiado dolor de cabeza.
speech to text, text to speech, to enable conversation between a doctor and a patient. But there's another really cool thing here that you'll see in a minute. There is a bot sitting behind the scene listening to the conversation. And the bot, because the doctor is currently dealing with many, many patients at the same time, they're more prone to mistakes. And the bot is connected to the electronic health records.
No haze para.
And is able to alert the doctor when the doctor is making a mistake. For example, the doctor is asking the patient to take aspirin. In this case, the patient is taking another drug that may interfere with aspirin. And the bot identifies that and alerts the doctor. The doctor makes a correction. And in another case, the doctor said, you know what, never mind the aspirin, take ibuprofen. And then it turns out that the patient is allergic to ibuprofen, and the bot alerts the doctor again, right? So the use of AI across the board here is an enabler, both for accessibility as well as for better health outcomes. And I'll take just one last minute to talk about one last problem that we see is very common. We live in a global world. Most companies and organizations have employees, partners, customers all over the world. And one of the things that we've been hearing from our customers a lot is that they're really concerned about confidential information and their IP being sent out there in the world when their employees need to communicate with other employees in a different language. I get that a lot, right? When I present something to a Japanese team and they say, can you send us the presentation? And then they run it through an online translation service just so that they can share it with their customer. One of our partners, 1 Hour Translation, actually an Israeli company, and they're present here today, has built a translation hub called Halo, which allows companies to insource, bring home all their translation needs. Basically, you can copy-paste content of email and translate them on the fly. You can translate documents, most types of documents that you receive from other employees or customers, or share with other customers in their own language. Talking about delighting the customers when you send a Japanese customer what you just presented to them in English. It also has a cool feature that you can add on, which is a chat where you can communicate multilingually, but that's not the cool feature. The cool feature is that when somebody asks you for your presentation and you said, sure, I'm sending it, you can send the presentation and it shows up in a different language on the other side. So, to conclude, we are at AWS focused on putting machine learning in the hands of every developer. As far as vision and language AI services are concerned, the common use cases in media, in contact centers, in document management and search are top of mind today. And I wanted to bring the real world a little bit to connect very shortly, very briefly, not so much deep dive, with the AI research and R&D and engineering aspect and bring those two together with some examples today. I'm more than happy to deep dive with anyone that wants to follow up. My name is Hershkovich, AWS. Thank you very much.